Alrighty, so going over your notes from yesterday, we have officially started a new topic, so that is very exciting. I really like this topic, so I think it should be a good time, hopefully. So the first couple lessons are just like intro type discovery, like we're not really sure what it is we're talking about, we're just noticing some patterns and things like that. So starting off with this first slide, it was just a notice and wonder. So there was no one correct answer. You just had to see things from the tables. So I want to go through a couple of the responses here. Again, answers are anonymous so that no one has to be embarrassed. Or they just don't like being called out in these. Alright. Okay, so this person said in the first table you're adding, in the second table you're multiplying, and in the third table you're subtracting and adding. So if I go up and look, I see yes, my y's are increasing by +5 each time in my first table. In my second table, they are getting multiplied by 2 each time, and then they noticed in this third table that they start to increase and then they start to decrease, which is where that adding and subtracting came in. So I think those are great observations. We see it goes up and down. I'm going to assume that they're talking about that third table where the y's increase and then decrease. The first table is going up by +5, and the second table is going up by ×2. Good. So, that's some good observations. So, let's look at our wonders. Okay, I wonder why the last one had a negative number. Yep. Not sure why that's the only one that went to the negatives. What are the three tables trying to represent? I think that's a very good question. Okay, right? In math, a lot of times our numbers are really talking about a certain situation or scenario. So what are these numbers talking about? Will they ever be the same at one point? I think that's an interesting question. What do the numbers in the x and y values represent? Awesome. Why are the x values the same in all three? Okay, I think these are some great questions. So let's continue. And now on this next slide, if it wants to move, there we go. I'm thinking some of us were confused on this. So we needed to draw a rectangle where all 4 sides added up to 50. So, like in this rectangle right here, if you guys can see, it's kind of small. They had the side, like the length being 10 and the width being 5. If I found the area of that, it would be 50 because it'd be 5 times 10. But if I'm talking about the perimeter, 10 plus 10 plus 5 plus 5 is only equal to 30. So that one does not work. Or like this one right here, the purple one. If I add up all the sides, 10 plus 10 plus 10 plus 20, I do get 50, but this is not technically a rectangle because in a rectangle, the opposite sides have to be the same length. Okay, so this is a good one right here. If I make it a little bit bigger. Okay, so if I add up 5 plus 20 plus 5 plus 20, I do get 50. So that is a potential rectangle that we could have used. Let's see if there's any other different ones. Being slow. Okay, here's another good one. Okay, if I add up 15 plus 10 plus 15 plus 10, I do get 50. Okay, so that is another option. So those are good. Hopefully we understand what we're looking for. On this third slide, you just had to create a second scenario. So you'll see a lot of the same, but remember the opposite sides have to be the same length. And if I add up all 4 sides, they have to equal 50. Okay. Alright. So moving on to slide 4. I'm going to have to click some of these to make them bigger. But you had to finish filling in the table with different possible lengths and widths. So I will, let me try and find one. Okay, I'm going to pull up this one. Okay, so this one looks awesome. So, and I think this was a little confusing, I think, in my video. So the length or the width plus the length needed to equal 25. So if the length and the width equal 25, then that means I would double it to get the whole perimeter, which is 50. So that's why we're adding the 25. So 1 plus 24 is 25. 5 plus 20 is 25. 10 plus 15 is 25. 12.5 plus 12.5 is 25, so on and so forth. So your width and your length column should have added to 25. Your area column came from multiplying the width times the length. So 10 times 15 is 150. 12.5 times 12.5 is 156.25. Okay, so that's how we got the areas. And I love this response about anything interesting. The width of 12.5 and the length of 12.5 creates the greatest area. So that was an awesome observation. Okay, other things that you could have noticed is that it starts to increase and then it decreases again. So either one of those is what I was looking for here. Okay, so let's move on to the next slide. So you guys can see what some of our classmates have graph so far, and there are 3 that are awesome that I want to point out. So it's this first one, this middle guy right here with all the different colors, and the one right next to it. You guys can see that we've got like a hill shape going on, and that's exactly what we want to see. It's increasing for a certain amount. It reaches its peak here at the 12.5, right? On our last slide, someone made that observation that it has the greatest area when the length and width are both 12.5. And then it starts to decrease again as my length increases. So that is a perfect graph, and we see that it goes up and then it comes back down. Okay, so here I'm going to say what do 366 and 2266 represent the length and the area. So this one's pretty close to being good, perfect, where it's 3 and 22 are both the length. So those are your x coordinates, that's true. And then they probably meant both 66s would represent the area, which is true. Okay, good. 3 and 22 is length, 66 is both the area. So those 2 that I just pointed out are going to be the most accurate. Okay, could the point 125 represent the length and area of the garden? So the answer is no. And let's see who has a good reasoning. Okay, so here, if you add up 25 plus 1, it is over 25. So that's correct. So the reason really being is if 1 is our length, then that means 24 would be the width. And if I find the area with a length of 1 and a width of 24, the area is 24, not 25. So that's why the answer is no. Alright, on our last one, you just have to fill in a table again. Let me try and find someone that did it right. Okay, so this one is close to being right. I'll change one thing. So this box is missing. So remember areas, length times width. So they did 20 times 30 to get 600. Here, we had to find the width. Okay, your length and width needed to add up to 50 this time because the whole perimeter is 100. So 40 plus 10 is 50. The only mistake is this 100. So I should have done 40 times 10, and that should have been 400 in there. So that's the only mistake. Okay, I think, and then what do you think the graph would look like? They said with an area would be decreasing and be exponential growth. So it's not quite exponential growth because they increase, and then once they hit 625, they start to decrease again. So here where they said the area was going up and down, that's good. So essentially, it's not going to look like a line. What it's going to look like is that hill that we saw on the previous slide where it starts to go up. It's going to increase and then decrease. So it's going to look like a hill is what we're looking for. So I think if you watch this whole video all the way through, it should help you with some of the homework questions on the McGraw-Hill site, and I have it so you can also check your answers up to 3 times. So if you do, after you watch this video, if you do have any questions on the McGraw-Hill assignment, just send me an email, and we can either email back and forth, or if we need to meet, we can do that as well. So yeah, good luck on your assignment for today. Have a good one.